Hey, Math 1, I've got a new lesson for you, 2.6. We're going to dive in. I know I talked a little bit about how to deal with fractions in an equation, but I wanted this lesson, 2.6, to really just say we're focusing completely on solving equations that have fractions all about. And some of them actually have variables in the denominators of the fractions, and you guys might get a little confused about that. That's what this one's all about. So, let's get started. What happens when we have an entire variable expression on the top of a fraction, and maybe there's just one on the left and one on the right? Well, the first thing I want to highlight is the fact that if you see a negative that's in front of the entire fraction, okay? You see a negative that's resting in front of the fraction. A lot of people get confused about what they're supposed to do in that situation. Does negative 1/3 mean negative 1 over 3? Does it mean negative 1 over negative 3? Does it mean 1 over negative 3? Can we choose any one of these and just go with it? Well, the idea is to create a negative number through division, it's got to be a negative number divided by a positive, or a positive number divided by a negative. It can't be a negative divided by a negative because a negative 1 divided by negative 3 is positive 1/3. Now here's the unfortunate thing. When students oftentimes kind of guess their way through it, guess which one they pick? They almost always pick the negative over a negative because they think, oh, the negative is in front of the whole thing, so let's just make everything negative. No, I would advise that you stick with this one. Just bring the negative to the top. Bring the negative to the numerator and you'll be fine. So I'm just going to call this negative 1 over positive 3. All right, from there you can use pretty much the same strategies that we've talked about in the past. If you see multiple fractions in an equation, find common denominators first. All right? So what would be a nice denominator that divides 4 and 3? Well, 4, 8, 12. 12 would divide 4 and 3. So if I multiply the bottom of the left one by 3, I create a 12 on the bottom of this fraction. If I multiply the bottom by 4 over here, I get a 12 on the bottom of that fraction. What you multiply by the bottom must be multiplied by the entire top part. So this is 3 times 3x. So I'm just going to call it 9x right away. 3 times 3x is 9x. 3 times 1 is a positive 3. Okay? And then over here, I'm going to multiply that by 4 as well. Negative 1 times 4 is negative 4. So I found common denominators. Once you find common denominators, you can multiply both sides by 12. Multiplication property of equality. Yeah. So what does multiplying by 12 do? Well, 12 over 1, to multiply fractions, you can cross cancel. 12 divided by 12 is 1. Over here, pretty much the same thing. 12 divided by 12 is also 1. So you see, we can just make the denominators disappear every single time we find common denominators on the left and the right, because we can always multiply both sides of the equation by that denominator. So what are we left with? We're left with 9x plus 3 equals negative 4. So we can subtract 3 from both sides to get the common the like terms together, and we have to do it opposite if we're moving it. If we're moving it on the other side of this thing, the equal sign, we have to do the opposite operation. 9x plus 0, negative 4 minus 3. Remember, same sign, add the two numbers together. And it's going to be negative in this case. Okay, the last step, if you have a number in front of x that's just a nice, neat whole number, divide it out. No decimal approximations, please. Negative 7 over 9 is a completely reduced fraction. Leave it. So I have a clean x equals negative 7/9. So the task for today is all about, we're going to find common denominators, and then we're going to ditch the denominator. Ditch the denominator so that we don't have to deal with any fractions further. All right, let's press into this and see what kind of examples we come up with. Why don't you guys pause the video and try number 2 on your own? All right, we're back. You had 5x over 7 equals 4x minus 1 over 4. You should have multiplied both of them to get 28. All right, so I want to make a 28 denominator here and make a 28 denominator there. So I multiplied the bottom of this by 4. I got to multiply the top of this by 4. 4 times 5x is 20x. Yeah, I actually want to make this a different color. 20x, yeah, and then here, multiply this top by 7. Notice that I'm multiplying the entire expression times 7 and not just the 1 and not just the 4x. That's a big mistake a lot of students make. So 7 times 4x is 28x. 7 times negative 1 is minus 7. At this point, I've got common denominators. I am now going to officially ditch the denominator. All right, are they common? Yeah, so ditch them. So you're just solving 20x is equal to 28x minus 7. All right, get the x's on one side. I'm just going to move them to the left. So subtract 28x from both sides. I have 20 minus 28, which is negative 8x, equals 0 minus 7, so negative 7. Make sure you pay attention to the negatives. All right, I'm running out of room here, so I'm going to go over here. I have negative 8x equals negative 7. Divide by negative 8 on both sides. A negative divided by a negative is a positive. I've been seeing a lot of you guys making that mistake multiple times. Negative over negative equals a positive value. X equals positive 7/8. You can't reduce the fraction. You can't make it a mixed number if the top is smaller than the bottom, so leave it. 7/8. Number 3. Looks kind of like the same thing here. Why don't you guys try it on your own again? Pause. All right, we're back. Looks like 6 and 4 both go into 12. 6, 12, 4, 8, 12. So let's just do that right away. To get 12, I multiply 6 times 2. So I got to multiply the entire numerator by 2. Can you guys see that clear enough? I believe so. So then 2 times 2x is 4x. 2 times negative 3 is negative 6. I got to multiply this by 3 to get 12 on the bottom here. So I got to multiply the top by 3 to do that. So 3 times 5x is 15x. 3 times negative 2 is negative 6. This is where you ditch the denominators and solve. So you got 4x minus 6 equals 15x minus 6. Remember, the ditching is due to the fact that I can multiply both sides by 12 and it'll cross cancel it. So now I'm going to move my x's to the left. And notice I'm only combining x terms with x terms. I'm only going to combine constants with constants. So please be on the lookout of those very important fundamental things. Some of you guys you're just randomly, you're trying to take the 6 and combine it with the x. They have to have x's in order to actually add or subtract to one another. All right, so we got this zeroes itself out. This is 4 minus 15, which is negative 11. They're x's, so make sure you put the x. Minus 6 here equals 0 minus 6. I'm going to add those 6's together. So add 6 to the left to get rid of it. Add 6 to the right. Negative 11x plus 0 equals nothing. This is the mathematical equivalent to nothing. Okay, we just learned about special cases in the last lesson. Is this a special case? Not really. The x's did not cancel themselves completely out. I don't have a 0x. I have a negative 11x. The zero's on the other side. I still got to divide by the x term. Divide by negative 11. Divide by negative 11. So this creates a clean x. And then 0 divided by any number is just going to be 0 at the end. All right, so congrats if you got that answer. X equals 0. All right, last one. A little more complicated. I got variables on the bottom. There's a couple different ways to talk about this. Okay, so let's say we still just wanted to find common denominators, okay? How do you find common denominators when there's x's in there? Well, it just means that the denominator has to be the same in both parts, okay? Actually, no, I'm not going to go that route just now. I got a better idea. Consider this fraction over here. I'm kind of ad-libbing right now. Do you guys agree with me that 1/3 is the same as 3/9? You've thought about it? Hopefully you're saying, yes, Mr. Owsley, we agree. Okay, what if I were to flip the fractions? So I flip the left-hand side, and I get 3/1. Flip the right-hand side, 9/3. Do they still equal each other? Yeah, 3/1 is 3. 9/3 is 3. It checks out. What ends up happening is you actually can manipulate the fractions if you want to. If it's one fraction equals another fraction, you are allowed to say, hey, I can't do much with this 5x plus 7 and this 2 plus 3x business going on, but if I were to rewrite this fraction as its inverse, its flip, and I get 5x plus 7 over 5, that's a lot more manageable because I can deal with a 5 in the denominator. I would do the same thing to the right-hand side to establish like equality with it. I can't flip the left and say, hey, 3 equals 1/3. You can't do that. You got to flip both sides if you do this method. Nice. Now all we got to do is say 15 is the magic denominator, I guess. Because you take 5 times 3 to get 15, you take 3 times 5 to get 15, and then all I got to do is transfer that to the top, times 3, transfer that to the top, times 5, and you're left with 15x plus 21 on the left-hand side in the numerator. And on the right, you've got 10 plus 15x. So yeah, just so that this doesn't become a bloated explanation, I'll just leave you guys to do that for problems where you can flip stuff around. At this point, you'd be able to ditch the denominator and be left with 15x plus 21 equals 10 plus 15x. All right, hopefully some red flags are going off right now. You got a 15x on the left. You got a 15x on the right. Those are going to completely cancel out. This is 10 plus 0. This is 0 plus 21. 21 does not equal 10. False. Our conclusion would be that there's no solution. All right, before I end the video, I just want to clarify that it's not no solution because there were variables in the denominator. That had nothing to do with it being no solution. Everything has to do with the fact that the x is canceled out. That's why it's no solution. So don't just look at a problem like that and instantly tell yourself it's going to be no solution, because there's a good chance you'll be wrong. All right, guys, hopefully this was helpful and you enjoyed it. Thanks for watching. I'm going to post the second video of examples 5 through 8. Take care.